Good afternoon, class. We are looking at practice test for module 1, covering chapters 1 and 2. Here's chapter 2, linear functions, part 1. So linear functions, recall, dependent and independent variables. For an equation in variables x and y, if the value of y depends on the value of x, then y is the dependent variable and x is the independent variable. We are looking at a pair x comma y. So the discussion of relation, domain and range. We're going to look at the definition and the graphs. Relation, a set of ordered pairs. Domain, the set of all input values, the x values, the independent variable for a relation. Range, the set of all output values, the y values, the dependent variable for a relation. So if we are given in the form of a graph, you can see this one or this one. Domain is all possible values, the first coordinate, the x coordinates, the independent variable along the x-axis, you have this portion. Range is all possible values of y, the dependent variable, the second variable, which is the range. So for example, in this graph, the domain is, you can try to put it along the x-axis to see what it covers. It covers from here to here. And because of this arrow, this continues indefinitely. Because of this dot, it stops here. And the range is from -infinity and stops here. Function. A function is a relation in which each element in the domain corresponds to exactly one element in the range. We use vertical line test to check it out, or short VLT. If a vertical line can be drawn so that it intersects a graph at more than one point, then the graph does not represent a function. If a vertical line cannot be drawn so that it includes a graph at more than one point, then the graph represents a function. A function is one-to-one if each element in the range corresponds to exactly one element in the domain. And for that, we use horizontal line test. If a horizontal line can be drawn so that it intersects the graph of a function at more than one point, the graph is not a one-to-one function. So in short, the x coordinate can't repeat, it's a function. If the y coordinate can't repeat either, then it becomes a one-to-one function. All right. We want to find the domain of each function using interval notation. Whenever you have a rational function, in order to find the domain, you set the denominator equal to 0 and you exclude it. It's that simple. So in this case, 2x minus 1 is 0, and you exclude that. So if you set 2x minus 1 equal to 0, it results in 1/2, and it can't be 1/2. The way you set this up, you can say x can't be 1/2. In an interval format, you say minus infinity to 1/2 union 1/2 to infinity. What happens, you have a square root or any root where the index is even. When the index is even, What's underneath must be greater than or equal to 0. You move the 4, you make a negative, divide by 5, and that means anywhere from negative 4/5 to infinity. By the way, just to remind you, this is the case when the index is even. If the index is odd, for example, if you have cube root of x, there is no restrictions. The domain would be all real numbers. Okay. F of x equals x squared is a polynomial of degree 2 or a quadratic function. The domain for all polynomials is all real numbers from negative to positive infinity. So this is a polynomial of degree 2 or quadratic function. So why is that? It's a quadratic function. Any polynomial, the domain would be all real numbers. So in this case, cube root of x, the domain is all real numbers. Because the index is odd. For example, cube root of 8 is 2. Cube root of negative 8 is negative 2. No restrictions, everybody. That's why. What about this one? Rational function. Let me just write the name rational. You set the denominator equal to 0 and exclude that. X squared minus 1 is 0. X squared equals 1. X is plus minus 1. And you exclude that. So this would be the domain, everybody. And if we want to use an interval notation, negative infinity to negative 1, union negative 1 to 1, union 1 to infinity. Parentheses indicate that we are excluding the endpoint. So this is an interval format. F of x equals 2/3 x plus 7. The domain is all real numbers. You can say negative to positive infinity, all real numbers, because again, it's a polynomial of degree 1. This is a linear function. Determine if the graph represents a function, a one-to-one function, and find the domain and range of each using interval notation. Is this a function? Yes. Is this a one-to-one function? Yes. The reason why is very simple. It is a function because it passes a VLT. Just it passes VLT, vertical line test. It's a one-to-one function. It passes HLT, horizontal line test. There is no vertical line that crosses the graph more than once. There is no horizontal line that does the same thing. So what is the domain? Just lay this along the x-axis. Starts from here and ends here. This endpoint is not part of the domain, so makes it 2 to 8. 2 is not included. That's why we use parentheses for 2, bracket for 8, and the range is here along the y-axis from 6 to 8. Again, 6 is included, 8 is not. And we use bracket for 6, parentheses for 8. Part B, is this a function? Yes. Is this a one-to-one function? No. Why is that? There is no way to come up with a vertical line that crosses the graph more than once. But as you can see, just you can come up with a many, infinitely many lines that, for example, this one, if I draw one of them, just a horizontal line. They have the same y coordinate, different x's. That's why it's not a one-to-one. Now, what is the domain? As you can see, this point corresponds to this one. Okay. And well, actually, there's a hole here. So this would be the domain from -3 to 2. 2 is not included. -3 is. So bracket -3, comma 2 parentheses. What about the range? The range starts from here and it goes up to here. So everything is included in between. So bracket -5, comma 4, bracket. So the endpoints in both cases are included, everybody. The last one is neither a function nor a one-to-one function, because just look at the lines that there are. I mean, this line, for example, crosses the graph more than once. That's a failing the vertical line test. Over here, crosses the graph more than once. It fails both HLT and VLT. Domain, I hope you see the endpoint here. Endpoint here. So anywhere from -4 to 0, including the endpoints. That would be the domain. The range, anywhere from 0 to 4. So it's pretty straightforward, everybody. Given the function f of x equals to x plus 1, find and simplify f of x plus h minus f of x over h. And this is the difference quotient, and it's the rise over run in essence. Rates of change. The difference quotient delta y over delta x, which is equal to f of x up 2 minus f of x up 1 over x up 2 minus x up 1. If you look at this one, you have 2 points, you connect them. By the way, the line is called the secant line when you have a curve. and x of 2 minus x of 1, f of x of 2 minus f of x of 1 over x of 2 minus x of 1. It's called the average rate of change of y, or f of x with respect to x, over the interval of x of 1 to x of 2, and can be interpreted as the slope of a secant line, PQ. So that PQ, everybody, is a secant line. Now, if you look at the same thing, but from the point of view here, as we go from A to A plus H, in essence, we get a similar definition like this. If we put this one X, and this becomes X plus H, f of X plus H minus f of X over H. If you go with this is f of A plus H minus f of A over the difference of these two is just H. So if you change this to X, you get this definition. Okay, everybody. So that's pretty straightforward. All right. So there are different ways of writing that. M delta y over delta x, or this was mentioned, and this is this one, f of b minus f of a over b minus a, f of x minus f of a over x minus a. It really depends how you write them, okay? For example, you can say this is a, this is x, and it becomes this one. Or as you can see right here, this one is that. The bottom line is rise over run. Rise over run. Okay, so let's calculate it for this case. That means 2 times x plus h plus 1 minus 2x plus 1 over h. So replace the x with x plus h. So what do we get here? You see the expression, and this is 2x plus 2h plus 1. This is minus 2x minus 1. These two cancel each other. These two cancel each other. We get 2h over h, which is 2. It's very important to be able to handle this because we come across it often in calculus. So coming up with that and being able to simplify it. Given the function f of x equals 2x squared plus 1 and g of x equals 3x minus 5, find f of g of 2. All right. First and foremost, the operation of functions. F plus minus g of x is f of x plus minus g of x. If g of x is f of x times g of x, f over g of x is f of x over g of x. This is the sum, this is the difference function, okay? The product function, the quotient function. Composite function. By definition, f o g of x is f of g of x. And g o f of x is g of f of x by definition, everybody. So if you look at this one, for example, x is a domain of G and G of X is domain of F. In this case, X is a domain of F and F of X is the domain of G. So X is a domain of G. G of X is range of that. X maps to G, and the portion that maps from here to here becomes F of G of X. So this would be domain of F of G, and this would be range of f of g. Again, g maps x to g, and f maps x to f. Okay, x to f. Let's see what that means. For example, f of g of 2, first we're going to find g of a 2. That means that into this function, plug in x equals 2. This one is 6 minus 5 is 1. So we want f of g of 2, which is f of a 1. And now we are going to put the 1 into the f function. So 1 squared is 1 times 2 is 2 plus 1 is 3. So that's how it works. Okay. F of g of x, that's the general format. So simply put, it means f of g of x. So that means anywhere you see x in f, replace it with 3x minus 5. F of g of x, that's the meaning of it. So we are going to raise this to the power of 2. Remember a plus b squared or a minus b squared. So you square this one, you get 9x squared. You multiply this one and you get 15x times 2 minus 30x with a negative sign minus 30x. And this one squared, you get 25. Just to remind you, a plus b squared is a squared plus 2ab plus b squared. And if it has a negative sign here, it must have a negative sign here. Now we are going to distribute and we get 18x squared minus 60x plus 50. Everything remains the same except 50 and 1. They add up to 51. We're going to continue, and f of x is 2x squared plus 1, g of x is 3x minus 5, as it was mentioned. And we want to find g o f of x, which means g of f of x, which means put this instead of x here. That's the meaning of it, everybody. And so this is 6x squared plus 3, positive 3 and negative 5, they add up to negative 2. G o g of x, that means g of g of x, that means put this one instead of x. So over here we get 9x. Over here we get minus 15. And these two numbers, we add them up. We get 9x minus 20 as the final answer. We're going to continue looking at more example of the same thing, composite functions. We want FOF of -2. We have two choices. We can find FOF of x and then plug in -2, or just find the easy way f of -2 and find f of -2 first. F of -2 first, which means replace the x with -2. And all you have to do is simplify by raising this to the power of 2, which gives you 4. 2 times 4 is 8, plus 1 is 9. So you want f of 9. And f of 9, we plug in 9 into f of x. 9 squared is 81. 2 times 81, 162, plus 1 is 163. Determine if the functions f of x and g of x are odd or even, reminding everyone that when we say even function, f of minus x must be equal to f of x, symmetric WRT with respect to the y-axis. Odd function, f of minus x must be minus f of x, which makes it symmetric with respect to the origin, 0, 0. So all you have to do, evaluate f of minus x, evaluate g of minus x, and observe. So f of minus x means 2 times minus x quantity squared plus 1. As you know, because this is even, minus x quantity squared is the same as x squared. And that is identical to f of x. And by definition of an even function, f of x is an even function. So I believe it's pretty straightforward. We are going to do the same thing for g of x by evaluating g of minus x by replacing the x with minus 1 and observe. So what happens? This is minus 3x minus 5. And as you can see, it's not equal to g of x. So it's not even. It's not its opposite either. It's not odd. So it's neither. G of x is neither even nor odd. Find the average rate of change of each function on the specified interval where f of x equal to 3x on the interval of -1 to 1. Reminding everyone of the rate of change, the difference quotient, delta y over delta x is f of x up to minus f of x of y, the average rate, and reminding you of those formulas that were given. Okay, everybody. And so in short, we want f of 1 minus f of negative 1 over 1 minus negative 1 according to these definitions. F of x minus f of a over x minus. The best one is to look at this one, f of x up 2. This is the beginning, this is the end. F of x up 2 minus f of x up 1 over x up 2 minus x of 1 means f of 1 minus f of negative 1 over 1 minus negative. So now what is f of 1? I replace the x with 1 and I get 3 times 1. What is f of negative 1? 3 times negative 1. So let's write it. So 3 plus 3 and the bottom is plus. So 6 halves or 3. So pretty straightforward, everybody. What about this function? F of x equals 2x minus 9 on the interval of 4 to a. Again, f of x up 2 minus f of x up 1 means f of a minus f of 4 over x up 2 minus x up 1 means a minus 4. So what is f of a? 3 times a. I'm sorry, we're looking at this function. What is f of a? 2 times a minus 9 minus what is f of 4? 2 times 4 minus 9, and the denominator is a minus. Two a minus 9. This is 8 minus 9, which makes it negative 1. So plus 1 or 2a minus 8. We can factor the a minus 4 out of the numerator, and it cancels out the denominator, becomes 2. We want to find the average rate of change from 2 to 2 plus h. So f of 2 plus h minus f of 2 over 2 plus h minus 2. In essence, really, we are using this one class. So the bottom becomes obviously h. F of 2 plus h, that means 3 times 2 plus h plus 4. Minus f of 2 means 3 times 2 plus 4. So these two canceled each other, okay? Let's distribute. So notice 6 and 4 and minus 10, they cancel each other, they become 0. So the numerator is 3h, the denominator is h. And we get 3 as the final answer. All right, let's switch gears to graphing techniques, transformations, and here's the synopsis of that. Vertical and horizontal translations. We look at this graph, the function y equals f of x, and we are assuming c is a number which is positive. So when we have y equals f of x plus c has been shifted up by c units against c, we are assuming is positive. F of x minus c has been shifted down by c units. F of x minus c has been shifted to the right by c units, and f of x plus c has been shifted left by c units, assuming c is positive. Now, as far as compression, stretches, and reflection, let's look at the graph. If the function is y equals f of x again, and we are assuming c is larger than 1. That's the assumption. Over here, c is larger than 0 is larger than 1. For example, 2 or 1.5. So what is c times f of x? In essence, the y coordinate is stretching by a factor of c. It gets larger by that factor. So it moves up by that. And if it's 1 over c, it becomes smaller. The y coordinate gets smaller like that. If it's y equals f of cx, the graph of y equals f of x shrunk by a factor of c in the horizontal direction. If it's f of x divided by c, is the graph of y equals f of x stretched by a factor of c in horizontal direction. What happens when we put a negative in front of f of x? Minus f of x is the graph of y reflected about the x-axis. So we flip it over with respect to the x-axis, we make it minus f of x. But if we put the x in negative in front of the x inside the parentheses, we flip it with respect to the y-axis. Okay, and it's explained here. So y equals minus f of x is the graph of y equals f of x reflected about the x-axis because the point x comma y is replaced by x comma negative y. And y equals f of minus x is the graph of y equals f of x reflected about the y-axis because the point x comma y is replaced by minus x comma y. So the following function was graphed by applying transformation to a toolkit. By toolkit, we mean essential functions, elementary functions, the graphs that we are supposed to know, the functions that we are supposed to know, their graph. Write the equation of a function that matches the graph. First and foremost, reminding everybody about these elementary functions. F of x equals b or y equals b is a constant. So let's look at the graphs too. Okay. F of x equals x or y equals x is a graph of a line that goes through the origin. F of x equals x squared, it's a parabola looking like that. It doesn't have to be perfect as long as you know the general shape. Because when you know the general shape, you know the domain, range, intercepts, and so forth. For example, this one, domain is all real numbers, the range is only one point b. This one, the domain and range are real numbers, all real numbers. This one, the domain is all real numbers, but the range is from 0 to infinity. Y equals or f of x equals x cubed, looking like that. Domain and range would be all real numbers. Y or f of x equals square root of x looks like that. Domain and range from 0 to infinity. So domain from 0 to infinity along the x-axis, range along the y-axis. And the cube root, f of x equals cube root of x, also the domain and range are all real numbers. Another one of those essential functions would be an absolute value function. An absolute value function looks like a V shape, everybody. It looks like a V shape. And it has the equation y equals absolute value of x, where the vertex This one is the vertex. This one is the vertex for a parabola. Is located originally at 0, 0. Now, if you want to see what happened here, just follow the vertex. The vertex from 0, 0 goes to what? 3, -2. So you follow y equals a times the parentheses or brackets x minus h plus k. You follow that. And you can easily find the answer. So the vertex has coordinates 3, -2. H is 3. And k is -2, so including the sign. Then how do we find the actual function? You pick up some easy points. For example, clearly this is 1, 0. Okay, this is 0, 1. So you pick those easy points and plug it in. When you plug it in, it can give you a, and in this case, because you already have the vertex, just 1 point will do the job. So let's go with this pair. That means replace the y with 0, x with 1. So y is 0, x is 1. 1 minus 3 is -2. And it's an absolute value, which makes it 2 times a minus 2. 2a minus 2 is 0, a becomes 1. So now plug it in here. And f of x is the absolute value of x minus 3 minus 2. Now it's important to check when you come up with the answer. So how do you check? Pick a different point. We use this point. Now use this point, see if it works. If I plug in 0, I get -3. Absolute value is positive, 3 minus 2 is 1, as an example. You can pick another point and check it. Just 1 or 2 points to make sure you haven't made a mistake, and it can easily give you the answer. The following function was graphed by applying transformation to a toolkit function or essential functions, such as f of x equals x squared, f of x equals square root of x, so on and so forth. Write the equation of a function that matches each graph. So it's important to know the shape of those graphs we just went over, and so you should recognize this as y equals square root of x that has been moved somehow to this location. We will figure it out in a moment, but you should know this graph. So this one has the equation y equals square root of x, and this point is a very important point. It's at 0, 0, which has been shifted to this location, which has the x coordinate -3, y coordinate -1. So it's been shifted. This point has been shifted to this point with coordinates -3, -1. So, okay. So we can notice that the general graph would have this equation something times square root of x plus k. X has been shifted to the left, so it's been, remember, plus 3. That's the meaning of it. And k, it's been shifted down by -1. So you put plus 3 here, -1 here. Remember, x plus 3, that means shifted to the left. -1 means shifted down. So shifted to the left by 3 units, shifted down by 1. Okay, so again, pick an easy point like this one. And make it work. Just plug it. Which means replace the x with -2, y with 0, everybody, and observe. This is 1, comes out as 1. So a minus 1 is 0, a equals 1. So if a equals 1, we get y equals square root of x plus 3 minus 1, which means this one has been shifted to the left by 3 units. So it made it square root of x plus 3, down by 1, so minus 1. That's how you come up with that answer. This graph now, the following function was graphed by applying transformation to a toolkit function, insertion functions that have been mentioned, etc. Write the equation of a function that matches each graph. And I hope you recognize this as a parabola. So the basic one is y equals x squared, and we should know the graph looking like that. So we have a vertex at 0, 0 originally, but it's been shifted here, -1, comma 2. So we have y equals a times x minus h quantity squared plus k, the vertex format. In some text, they call this standard form of a quadratic function. And x minus h, that means x, it's been shifted to the left, x minus -1 or x plus 1 plus k, that means plus 2. And all you have to do to find a, because you have the vertex, if you didn't have the vertex, you need 3 points class. But because we have the vertex, we only need 1 more point. And clearly, we go with easy points. This has coordinates 0, 1. So replace the x with 0 and y with 1. Obviously, this is 1, square root is 1. A plus 2 is 1. A must be -1. And all you have to do, replace this here. And the function y equals minus parentheses x plus 1 squared plus 2. And I'm sure everybody remembers dealing with parabolas from before. When a is negative, it opens down. So you can easily figure it out in this way. So before we move on again, all the basic functions, elementary functions, they also call it toolkit. We should know the graph, okay? Now, In this example, find the equation of a function that is finally graphed after the following transformations are applied to the graph of y equals x squared. So we are given this graph y equals x squared, and we are going to make changes. We are going to shift it 3 units to the right. So that means x becomes x minus 3. So f of x is x minus 3 squared. Reflected about the x-axis. So that means you put a negative sign in front of the function. You want to negate the y, so you negate that. Now, of course, we are working on this one, okay? When they say following transformation, that's the first transformation. The second one is working on this one, not the original one, okay? Continue the way the question is asked, unless it says do the transformation to the original function. No, we are doing it to this one, which means now we put a negative in front of this and becomes f of x equals minus parentheses x minus 3 quantity squared. Finally, we're going to shift it down by 2 units. So the previous one, this one, we're going to shift it down by 2 units. We are going to add -2 or simply subtract 2. This one becomes f of x equals what we had in the previous step, minus the parentheses x minus 3 quantity squared, and then 2 units down, -2. That's how we arrive at the final answer here.